The word ethane has increasingly surfaced in space development circles. Traditionally associated with city or natural gas, methane is now making its mark as rocket fuel. SpaceX and Blue Origin are among the companies adopting it as a next-generation propellant. Its rise begs the question, why is methane suddenly capturing so much attention in the race to shape the future of space travel? What is methane propellant? Methane propellant refers to rocket fuel that uses methane as its main component. The gas is cooled to extremely low temperatures to liquefy it, enabling its use as fuel in rocket propulsion systems. Comparison with traditional fuels. Rocket fuels are typically divided into three main types: kerosene, liquid hydrogen, and methane. Kerosene is easy to handle and store, which shortens launch preparation time and simplifies management. However, it leaves behind soot and carbon residue inside the engine during combustion, requiring cleaning and repair for reuse. This is a notable limitation for the modern space sector, which prioritizes reusability in its designs. Liquid hydrogen provides high fuel efficiency, but must be stored at -253 degrees Celsius to remain liquid. This creates difficulties in storage and increases the risk of evaporation or leakage, posing challenges for its use in rocket propulsion. Methane sits between kerosene and hydrogen. Its energy efficiency is higher than kerosene but lower than hydrogen, while being easier to manage than hydrogen. Methane liquefies at -162 degrees Celsius, which makes it easier to store and less costly to cool compared to hydrogen. It burns cleanly, leaving little to no residue, which makes it ideal for reusable rockets. Pros and cons of methane propellant. Methane propellant brings crucial benefits and promising prospects for space exploration. A key advantage is its potential to be manufactured on Mars, which boasts a carbon dioxide-heavy atmosphere and likely underground water. By combining these resources, methane fuel can be produced in situ, meaning spacecraft wouldn't have to carry all their return fuel from Earth, enabling more sustainable Mars missions and easier return journeys. Methane is also versatile beyond its role as a fuel. When burned, it produces water and carbon dioxide, meaning that, with the proper equipment, water can be generated inside spacecraft. Additionally, methane is relatively simple to refine and store, and it can be mass-produced at low cost. However, methane does have its drawbacks. Rocket engines that use methane are still in the early stages of development, so operational data is limited. Also, keeping methane in liquid form requires cooling systems, as well as insulation and pressure regulation in fuel tanks and pipelines. Furthermore, methane has the potential to explode if combustion conditions are not met, making precise control technology essential.